So we're going to do more practice on what we just went over. So you can see the first few questions are exactly the same. We're going to be very conscious of that the answer here is not 3. Right? The answer here is not 3. If we solve this for 0, and we did the whole negative b over 2a and graphed this whole thing, did the whole t-chart, we'd see that it looks something like this. The vertex would be at 0, negative 9, since there's no b value. Vertex is at 0, and the y-intercept is negative 9, and that there are 2 answers. And those 2 answers are what? What are these 2 answers? Where does this graph intersect? 3 and negative 3. So the answers to this question right here, by taking the square root of both sides, okay, gives us these x-intercepts. We get 2 answers. X equals negative 3 and x equals positive 3, and write your answers in this format. Okay. So we're always relating it back to a graph. We're always thinking it's a quadratic. This is the what we call a projectile equation. Right? So if something's going up in the air, coming back down, it has to start up from someplace, has to land someplace. That's why we have 2 answers. And we'll go down here, and we might have something in front of it or behind it. Just think, use your intuition that if you had like 4p equal to 8, how would you solve this? Yeah, you divide both sides by 4. So you can see that it's very similar. We're going to do the same exact thing you would always do. So we might have to now do something a little bit more than just start off by taking the square root. We have to set it up for the square root first. So now we have p squared equals 100 divided by 4 is 25. And now you can take the square root of both sides. So p equals negative 5 and 5. Of course, if I asked you to, graph this, tell me what it means, you draw a rough parabola like this and say, oh, that's at 0, comma negative 25, and those x-intercepts are 5 and negative 5. That's what you would draw me. Just from having this equation, just by giving this answer, that could be a nice question. If you get an answer of negative 5 and 5, what does that mean graphically? You can draw this whole thing. Similar over here, number 4, we might have to add and subtract. So if you just had like n plus 2 equals 2, you would subtract 2 on both sides. So we'll do the same thing here. So if you had this intuition like, well, I just do this, that's all I have to do, it's probably correct because we're doing the same steps we've always done, except at the end you're square rooting. But other than that, it's identical. So we have n squared. What number squared equals 0? 0. Is there only one answer, though?
No.
What other number squared equals 0? Okay. Yeah, no negative, no positive. So 0 is this kind of exception, right? I just got finished saying how, hey, you always have 2 answers. You always have 2 intercepts. Is it possible to draw a parabola that only crosses the x-axis here at 0 one time? How would you draw that? Is that possible, or what would it look like if this parabola only crossed the x-axis at one point? Well, it's still a parabola. It's not a different shape all of a sudden. Still squared, right? N squared. So think about this. How about this? Does that work? Is there only one x-intercept now? Is that x-intercept 0? Yeah. So the vertex is also the x-intercept. So when you have one solution, the vertex is also the solution. Over here we had a vertex that was negative 25, but the solutions were negative 5 and 5. So if we have one answer, we have one x-intercept. Going off of that, is it possible to have no solution? Is it possible to have a parabola that does not cross the x-axis at all?
Yes.
And what would that look like? What would a no solution graphically look like? Yeah. Are there any solutions here? No. Does it cross the x-axis? No. No solutions. Now, how would you get a no solution from an equation? What would that look like? What if it was like n squared equals -9? What happens when you try to take the square root of both sides? Right? What times itself equals -9?
9 and
3 and 3 is +9. That doesn't work.
-3 times
-3 and -3, that's +9.
-3 times
It has to be the same number. It's the square root. So is it possible to take the square root of a negative?
No.
No. That's how you get a no solution. So if you ever have a square root of a negative, that's when you get the no solution. Take this and solve it as if you're going to graph it. What would you do? You'd add 9 to both sides, see? You get this, and if you try to graph it, yeah, the vertex is at 0, 9, and it's opening upwards. So yeah, there's no solution. No solution. So we have 3 types. We have 2 answers, which happens most of the time. We have the case where the vertex is also the x-intercept. That means there's only 1 answer. And then we have the case where there is no solution. It doesn't cross the x-axis, or you'd have to take a square root of a negative, which is impossible for you right now. Okay. So those are your 3 cases. So you're going to go carry on through these problems. You're going to be okay with something like 7. Right? Right? We're going to venture away from the idea that the right-hand side needs to be a perfect square. So far, everything I've given you on the right-hand side, it was 25, 81, 36, 49. Well, there's a lot of other numbers that are not perfect squares, such as 31. So what happens when you get an answer of like square root of 31? How do you write that? What do you do? First of all, is this still count as an answer, even though you can't take the square root? Does it still count? Or do we say no solution, forget about it? Right. Still counts. What number is this approximately, by the way? 5.5, 6, or 7, something like that. Yeah. Square root of 25 is 5. Square root of 36 is 6. So we know this square root of 31, which is between 25 and 36, is 5 point something. It's still a number. We could still go here and say, okay, this is about 5.6 and negative, and this is about 5.6 positive. So yeah, you can still graph it and everything. It's just kind of ugly because it's really not 5.6. It's 5.62813, 5.6, 281. You know, it's this long decimal. So instead of writing out this as our answer, we're just going to leave our answer as negative root 31 and positive root 31. We just leave it like that. Okay. Of course, we're going to check to see if it does reduce as a radical, but we can just leave our answer as this. There's still 2 answers, right? They're just these decimals that we need a calculator to calculate. And we'll look at that next time in Algebra 2 when we start using a calculator heavily. But sometimes people say, well, I can't take the square root of 31, therefore there's no solution. That's not correct. We do have answers. They're just long decimals. Okay. What if this came out to be x squared equals 8? Don't write this down, but just watch. I take the square root of both sides. Would I say my answer is square root of 8 and square root of negative square root of 8? No, because root 8 reduces. So we just spent last week reducing radicals. So sometimes they don't reduce, like 31 doesn't reduce, right? But root 8 is going to be root 4 times root 2, which is 2 root 2. So just like reducing a fraction, if you get an answer of x equals 8 over 16, you know automatically to reduce it to 1/2. If you get an answer of root 8, you have to know automatically that you need to reduce it to 2 root 2 and negative 2 root 2. And make sure those are your answers. Okay, make sure those. So you might do your work. If this is multiple choice, you could swear that, oh no, it's got to be radical 8, but it's not there as ABCD because you didn't reduce it. So you have to reduce it. So if you still need to use your chart that I gave you last week, that whole chart there helps you break it down, you can use it, but hopefully you want to get away from doing that after a while. So you might have some that, yeah, wrapping it up, you might have some like this. They don't reduce. The answer is already 1/2. You might get some like this, which you have to reduce. You have to reduce it without being reminded or told, just like a fraction. Can't say, oh, I didn't know I had to, or something like that. Make sure you do it. All right, so that'll wrap up the front. Going to the back side, flip side. Basic factoring, just remember to factor. The GCF first. Always start with the GCF. That's usually the Achilles heel, they call it. If you forget that, it kind of messes everything else up. Is this a perfect square trinomial? So can we just say this is like x plus something squared? Or do we have to do the full box?
You can do F plus something squared.
Can you? So let's check. Is this the right number? Is 36 the right number? So if we take half of 5, what do you get?
2.5.
2.5. Is 2.5 times 2.5 equal to this?
No.
No. So it's not a perfect square. Another giveaway is what?
Negative.
That's negative. Right? When we square it, you always got a positive. So if that's a minus, it's not a perfect square. It's not going to work. So we have to go back to our old roots here and say, what two numbers multiply to negative 36x squared and add to 5x? So it's important once we start doing new stuff that seems really easy and quick to do, we don't forget that we can't do that on everything. There's certain conditions to use certain tools, and we can't just disregard what we've learned in the past. Alright, so here we go. What two numbers multiply to negative 36x squared and add to 5x? 9x minus 4x. There you go. So we can go over here. We have x squared, negative 36. Okay, go ahead and make our box. The hardest thing after we learn how to do this stuff is not mixing up when to use it. Okay? Knowing when we have to go back to our roots, knowing when we can use our shortcuts, but don't try to use the same thing on every single problem from now on. Keep in mind, we can only use it in certain circumstances. So I checked it. I took half of this number, right? Squared it, see if it followed this model right here, right? So if the number doesn't match up, I need, only one square. If you don't have a plus 1 there, something's wrong. Okay, so we just have to factor it right here. And again, don't forget the 5 in the front. Some of these have a GCF, some of them don't. 17 and 18, just practice graphing. We've been doing plenty of that. And when we get down to here, more practice finding the C. What's half of negative 34? Half of negative 34 is 17. 17 times 17. I'll let you go ahead and factor it or multiply it and figure it out. So we'll do the same thing. A little bit of everything. All right. Good luck on that.